Morning.
Waalaikumsalam. Good morning, sir.
Okay, so hari ni kita buat kelas juga walaupun cuti, sebab saya nak mengelakkan mengganti kelas yang terlalu banyak sebab kita pun ada satu lagi kelas yang kita tidak ganti semasa cuti banjir tu. So kalau tambah hari ni kita nak ganti, saya takut nanti tak mampu dan tak larat sebab kita pun masing-masing sibuk. Jadi saya terpaksa gunakanlah cuti supaya kita mudah nanti. Okey, saya tak nak bincang dengan banyak topik hari ini sebab topik kita agak pendek saja hari ini. Sebab pada minggu lepas kita dah buat about bar. Jadi untuk TRUSS sebenarnya adalah lanjutan daripada bar. So that's why saya takkan banyak more on teori. Terus saya akan buat demonstration. Sedikit sajalah cerita about the TRUSS and some of the example dia punya application and straight away to the application using MECWAY directly. Okay, so I will share the slides. So the topic today is to use finite element method software, which is that as MECWAY, to solve a civil engineering problem, which is we are focused on the TRUSS structure. Okay, so this is our learning outcomes. We are using the same learning outcome that we have used before last week by modeling the structure. So you did also on the last week where you model the bar structure. But now we are using TRUSS element. So this is a special element that you use for TRUSS. And then you have to propose a proper element types. Proper element types, which is usually by using one dimensional, and then you are using line 2, not using line 3, and propose the meshing number depending on your selection of the element types. And macam biasa, you have to assign the member sections plus also the properties, the material properties. Material properties, assign the loadings and also the corresponding boundary conditions lah. So usually TRUSS ni kita akan ada boundary condition to be pin and roller. Either to be pin or roller, or maybe sometimes so you have sliding. So sliding ni macam roller sebenarnya. So this is the commonly support condition for our TRUSS. And another one is the free end. Free end. So these will be some of the example of boundary conditions. After that, you use the solver to run the analysis where you get the results. So the result will be the displacement, the reactions, your axial forces, and for sure you want to know what is the stress inside the element. So those are the almost similar learning outcome they have done last week, and we want only to repeat to this TRUSS element. Okay, TRUSS. I think most of you know about TRUSS because you have learned it from your structural analysis, either to be determinate or indeterminate. It's a structure composed of maybe slender, depending on the cross section, where you will connect them at their endpoints. And when you connect them at their endpoints, usually you will use bolting system. You will use either to use bolts or welding. So maybe you are welding to a certain plate that we call as a gusset plate, so that you can transfer the axial load and there is no moments generated at joints. No moments generated at joints. So that's why you have the equations, the three equilibrium equations that you have to find the summation of moment, the forces in X to be 0, summation of force in Y to be 0, and also the summation of moment at any joints also to be 0. So this is why there is no bending moment generated inside truss, because you always assume that there is no bending moment at the joints because of these equations. And we have two types of connection system, either to use by using bolts or you can use welding. Okay. So I don't want to talk a lot about the theoretical part because Dr. Noshike will tell it about it to you, and I just want to show directly how you can use MECWAY to model truss structure. So let's say you are given a simple truss structure, yeah. Okay. So maybe this truss structure is called as Pratt truss structure. This is the name for this. Carrying some vertical loads. You may see that there are similar vertical loads acting on the joints A, joints B, C, and D. And joints A will be a pin supported here, and joint E will be a roller supported. Okay, so by using the finite element software, you are required to model the truss structure so that you can get these outputs. Okay, you want to know what is the reactions at supports A and E. We want to know what is the axial forces in each members. Kita ada banyak members kat sini, as well as the stresses. And the last part is to view the deformed shape, and we want to know what is the maximum deflections. So the properties given for this truss is 205 gigapascal, the Young modulus. So we don't have any Poisson ratio, and we don't put any what you call it, this density. So if let's say this information is given, you have to include. But in this example, I don't include any Poisson ratio, and there is no density for the material. Okay, so what should be done in the beginning? We have to model what is the nodes coordinates. So you can see that here we have a lot of elements. So this is your element number 1, element number 2, number 3, number 4, number 5, 6, 7, 8, 9, 10, 11. So I have 11 elements here, and you have some number of nodes. That is nodes 1, 2, 3, 4, 5, 6, 7. So I have 7 nodes, 11 elements, and 7 nodes. And I will assume that at joint 1 here, so at joint E here, this is where my x-axis, and this is where my y-axis. Okay, so we can model this by using MECWAY. So I will open directly MECWAY. Okay, and I will model each of the nodes. So we have 7 nodes. So I will have to know what is the coordinates of nodes 1 until node 7. So I will start my nodes number 1, which is 0, 0, 0 in meter. Okay, it will be there. So nodes number 2 here. So I can use another feature here called as relative to previous. Okay. So nodes number 2 is about how many meters from nodes number 1? It's about 2 meters each. Okay. Nodes number 2 is 2 meters apart from nodes number 1. So I will put the direction is to be 2 meters in x directions. So you can see that is in the x direction. I will add. You can see that that is the second nodes, as well as of the for the third nodes, which is also 2 meters from the previous. So I will add. So if you zoom to window, okay, you may see that this is my third nodes, which is here. The fourth node also will be 2 meter. So I will add, zoom to window. Okay, so this is my fourth node. Okay, and I want also to create nodes number 4. Sorry, 1, 2, 3, 4, 5. So nodes number 5 here, I can use relative to previous. I think I can do also relative to previous, but I'll use in Y directions. Okay, so the distance from nodes number 5 to nodes number 1 is about 7. So that will be -7, because it is downwards. So I will add that, and if I zoom to window, so something is not right here. So see, should be this is 7 meter downwards. So never mind, we can delete this. So you can click on the mesh tools, nodes element list. So before that, I can also undo. You don't need to click that part. You can also use this feature, undo. So undo the whole thing. Okay, so just check. Okay, so I have to activate the nodes number. Show the add nodes number. So this is node number 5, which is wrong. So I have to go to the mesh tools, nodes element list, nodes number 5, you can delete. And it's gone. Okay. Okay, should be in Y direction to be 97. Oh, because this is relative to previous. Okay, never mind. We have to close this first. And click this again. So I think we have to insert that nodes manually. So that will be 097. So this one. Okay. And we have to join from this to this. Oh, I have to calculate the distance. So it's better you create an element using line 2. Yes, any questions? Siapa-siapa nak tanya ke? Saya dengar macam buka mikrofon tu. Yes.
Sir,
Ya,
yang 7 tu bukan negatif 2.5 ke?
Oh, ya, saya pun tak pasti. Sekejap. Ya, betul. Saya pun silap. Nasib baik saya tak cantumkan lagi. Never mind. So, yang ni kita delete balik lah. Tak ada masalah. Kita delete balik. Kesilapan berlaku. Delete ataupun edit pun boleh. Senang edit lah. Tak payah nak delete. 92.5. So, klik OK. Klik close. Dia jadi rapat lah. And then zoom to window. So, much more better. View. So, click this element. Kita cantumkan elemen-elemen ni. Okay. And we have also to click this until this. Okay. So now I want to divide this into how many sections? 3 equal sections. So I can click on this element and click on the mesh tools and try to divide it into 3 equal. Sekejap, saya tengah tengok sini. I think I want to use this much more better here. Okay, never mind. So for this, I want to delete. So you can click that part and just click delete. Okay. So you can click this part, create, and click curve generator. Okay, this is a new features for you. Click on the straight lines. Okay. Should be the mesh to be you have 3 elements. Straight lines. Okay, so the number of nodes will be 2. Betul. So kalau tengok betul-betul you have 2 number of elements, nodes. Saya pun tengah cuba ni. So maybe the nodes is 2. Okay. So our straight line coordinate will be 0, and then this one will be 5 tadi ialah negative 2.5 kalau tak silap saya. And our coordinates di sini will be a 0, 8, 0. Okay. So 800. Okay. So click OK. Cuba tengok jadi tidak, saya tak pasti lagi. So number of elements to be 3. Cuba tengok apa jadi. Oh, tidak jadi sangat jauh ke sana. 2, 4, 6. 6 ke 8? Saya kena tengok balik. Oh, 6. Saya pun silap. So, kita undo balik. So, tak susah hati. Kita boleh undo dengan redo. No problem. Click on the straight line. Yang ini sepatutnya 0, negative 2.5. Yang ini sepatutnya 6. Saya pun silap tadi. So, number of nodes is 2. And number of element is 3. So, click OK. So, nampak dia ada 3 elemen. Nampak? Created automatically. So, by using this feature, you don't have to know what is the coordinate of these nodes. Kalau tidak, teruklah you nak kena kira dengan calculator kan. You nak kena tahu nodes ni berapa. Dan dia dalam bentuk perpuluhan kan. Leceh kan. So, better you use that feature where you can dissect. You can bisect that element into 3 automatically. Okay. So, if I turn the nodes number. Okay. So, I can select my element here. Cuba tengok gambar ni macam mana gambar dia. So, kita cantum yang ni. Okay. So, I will select this part and this part. Nampak? Easier. Okay. And then macam mana lagi dia punya sambungan tu? Oh, dia bentuk L macam ni. Yang ini kepada ini. And this one to this one. Okay. So, easy if you use this mesh tool, create curve generator. Then you can bisect atau you can divide that length straight line kepada bahagian yang berapa panjang yang sama lah. Okay. Rather than you have to put the coordinate of 7 and 8 lah, which is very, very cumbersome. Okay. So next part after this is to rename. So I want to rename according to the sections. So kalau you tengok dekat bahagian top chords. What is top chords? Top chord is adalah bahagian yang atas sekali. So, kalau you tengok kat sini, if I remove all of this. So, this is that we call as top chord. Top chord. And that top chord is made by a rectangular section solid 0.7 by 0.7. So, ini maksudnya segi 4 solid 0.7 by 0.7 meter. Dia punya section. It's a solid. Or bottom chord yang bawah ni lah. All of this kita panggil bottom chord and made by a circular hollow section. So ini dibuat dengan bulatan berongga where you have a solid part here. And then diameter is 0.6. The diameter is 0.6. And then thickness is 0.2. So tebal dinding berongga ni 0.2 mm ke meter? Meter. Okay. And apa lagi? Intermediate chords. Intermediate chord maksud yang dalam lah. Semua benda ni yang dalam ni. Kita panggil sebagai intermediate chord. The section is rectangular hollow section. Oh, okay. So yang ini pula jenis yang begini. Dia solid dekat situ tapi dia ada lubang kat tengah. Berapa size? 0.6, 0.6. So 0.6, 0.6. Tebal. Tebal dia sama macam circular tu lah. Ini kita nak buat. So we want to construct this according to the given sections. Okay. So to do that, it's better we rename the elements. So we select this element. Okay. So we name it. Rename it as top chord. Kita namakan senang. Jadi bila saya pilih ini, nampak dia terus pilih the top chord. The same also for the bottom chord. So please push your control button. Push your control button. So select the element. Push control button sampai warna biru tu keluar. Push control button, jangan lepas. So you select them simultaneously. Right click, new components, and then rename it as bottom chord. Okay. Yang lebih tu yang default, nampak dia akan pilih yang tengah tu, that will be your intermediate chord lah. I will name it as intermediate chord. So senang, bila kita nak buat design, nampak kita boleh pilih ni, terus dipilih. Terus dipilih. Senang kita nak assign material. So I will start with the top chord. Nampak tu, right click, assign new material macam biasalah. And then you have upper section ni, tengok. Oh, dia solid. Solid maksudnya rectangular bar. Okey, size dia berapa? 0.7 dengan 0.7. 0.7, 0.7. Okey, dia akan cut it automatically. And the isotropic will be 205 lah. So yang lain tak ada. So just click OK. Finish. For bottom chord, assign new material also. Section dia rectangular hollow section. Circular tube. Where your punya outer diameter is 0.6 kalau tak silap saya. And then dia punya inner diameter. So maksudnya 0.6 tolak 0.2 lah. So the inner diameter will be 0.4 lah. Itu maksudnya inner. O itu maksudnya outer. 205. And that's it. And for the intermediate chord, assign new material. Saya rasa adalah rectangular tube. Rectangular tube. Oh, sorry, bukan ini. 0.6 kali 0.6. A dia 0.6. B dia pun 0.6. C ni tebal. Tebal tadi 0.2. Kalau tak silap saya. So, this is 205 and that's it. So, kalau nak tengok dia bisa in 3D, you can click this. Sorry. Ni, nampak ni? So I can rotate. Even nampak macam dia bina tu. So you can view lah dia punya shape tu macam mana. You can view. So I will turn off this feature and show back in the 2D and in the zoom fit. And close this. Setakat ni ada soalan tak setakat ni? Ada apa soalan?
Okay, just
Okay. What you have done is a structure that can still transfer bending moment. So macam mana nak buat benda ni tak boleh transfer bending moment? So one of the way is you just click this top chord, right click of your mouse, element properties. Please click this truss feature. Kalau you tak klik this truss feature, you punya structure akan ada bending moment. So click this truss. Do the same thing also for the bottom chord. Buat benda yang sama. Right click. Sampai keluar element properties. Truss. And the intermediate chord also. You have to right click here. Sampai keluar element properties. Right click ni. Nak klik ni bukan senang. Kadang-kadang keluar. Okay. And truss. Okay, so now when you do that, you have already convert that structure into truss structure, where it does not carry any bending moment and shear force. Kalau you tak klik truss tadi, you akan dapat bending moment and shear force, which is not correct for truss analysis. Okay, next is to assign the loads lah, 12.5 ni. Okay, so just click this nodes. I will select these 4 nodes simultaneously. Right click, loads and constraint, new force, acting in y directions. Sebanyak berapa? 12.5 kilonewton. So this must be in kilo, in y, negative 12.5. Click OK, you will nampak. All loads are there. And now to assign our pin support here, So I have to select nodes number 1. Nampak tu? Is being selected. Right click. Loads and constraint. New displacement. So your displacement is the displacement in X direction will be constrained sebab pin. Displacement in Y also will be constrained. And also in Z. Z direction also will be constrained. So saya akan buat semua ni constraint. You boleh buat sini new pin support pun boleh. You nak buat new displacement pun boleh. So saya letak new pin support. Klik OK. So nampak? And for our roller supporter will be here, which is not moving in X direction. Y dia boleh move, X direction tak boleh. So I will select this part. Loads and constraint. New displacement. Tak boleh bergerak dalam arah X. Jangan klik arah Y. Arah X. Okay. And I will click OK. And you can see that there is a reactions there, stating that it's a roller support. Okay. So you can save your file. Saya bagi nama TRUSS. And then you run it. Should be there is no problem. Okay, kalau hijau ni there's no problem. Okay, what we want to know, our reaction at supports. Okay, so very easy. You just click because kita ada pin support here and roller support here. So you have two type of displacement, which is in X. So ini saya tukar kepada milimeter. And in Y, nampak ada displacement. In Z, there is no displacement, kosong, tak ada displacement. So, if you want to know the resultant displacement, you can click on the magnitude. Okay. So, this is in X, this is in Y. Okay. So, displacement is quite large, because kali 10 kuasa 18, very large. Why? Because the young modulus is very, very not good. So that's why the reflection is very high. So if I want to see the displacement, sorry. So saya run sekali lagi. So if you want to know the displacement, okay, you can click this animation. You boleh nampak dia akan displace banyak tu. Nampak? Dia akan displace. So sekejap kenapa jadi begini, saya pun tak faham kenapa sepatutnya tak jadi begini. So I will exit first. No. I will open back my MECWAY. So kadang-kadang software ni ada problem sikit in terms of execution. Open that my file which is TRUSS. I rerun it again. And see the displacement. Okay. I can view the deform shape. Okay, too large. So kalau tengok di animation, so maybe why jadi begini sebab dia terlalu besar displacement. Nampak ni 10 kuasa 11 meter, maksudnya benda ni dah patah dah. Kenapa jadi gini? Because our load is too high, 12.5, and maybe our section is too small. So if you want to reduce the deflection, you can stop the animation and maybe I can change the size of the chord. You can change the size. So maybe 0.6 tak cukup kuat, maybe kita boleh letak 0.8 maybe. So nampak, saya boleh tukar. Ataupun kita buat yang ni lebih tebal lagi, katalah 0.4. Saya buat lagi tebal lagi. Let's say at bottom chord saya tukar juga lagi, saya edit. Katakan ini tak cukup tebal, kita buat 0.8, saya ada dengan 0.4. And let's say for our intermediate, ini dah buat lah. So kita tengok yang top chord. Top chord saya dah edit dah. So katalah ni saya buat 0.9 by 0.9. Let's say too big, besar sikit. And I will analyze it again and see what is the displacement. Still too large. So you boleh main-main lah dengan section ni until your displacement is within the required design. Sebab displacement ni too high. terlalu besar, kali 10 kuasa 9 meter. Besar gila, maksudnya sebesar matahari dia punya displacement. Quite big. So you kena play around, ada kalau nak tukar force pun boleh, nak tukar force pun boleh. Maybe the force is too high, so maybe I can choose maybe to be not kilonewton, maybe to 2 newton. Tengok ni apa jadi. Nampak displacement dah kurang. Tadi 10 kuasa 18, sekarang jadi 10 kuasa 8. Okay, so that is in terms of reactions. So kalau tengok reaction in terms of table pun boleh. You can click this new table. So sebelum tu kita hidupkan dia punya nodes and element. Okay. So kita boleh klik ni. Nampak ni, kita boleh tengok displacement mana kita nak. Katalah saya nak displacement at X direction, boleh. Okay. Katakan pada top chord saja, boleh. So I can update, dia akan bagi displacement at top chords only. Kalau kata you nak on bottom chords pun boleh, you update. Ni displacement arah X untuk top chord saja, bottom chord saja. Kalau you nak semua, you can click all. You click all, you click update, ada banyak result. So kalau nak result in displacement in Y pun boleh, you just update. Nampak? Dia akan bagi X tu. Ataupun you nak dapatkan displacement magnitude dia punya resultant boleh, you just update. So very easy. So you can copy to this clipboard. So you boleh copy semua ni. You boleh copy yang ni semua kepada clipboard. And then you can paste to Excel. So you can see here, I don't have to use any structural analysis. Saya tak perlu gunakan method of joints, method of section to analyze my truss. Nampak ni? This is my displacement. So kalau nak tengok gambar dia, boleh, tak ada masalah. Kita pergi balik pada sini. Kita screenshot benda ni. Sekejap ya. Saya kena klik screenshot as. And then we can paste here lah. Besar sangat gambar, kita kecilkan sikit. You nampak lah. Notes number 1 kat mana? Ni notes number 1. This is note number 2. So you nampak lah displacement dia. Okay. Ada soalan tak sekarang ni? Before we go to the next part, axial force. Ada tak soalan? Any questions?
So far tak ada, sir.
Okay, axial force, you have to click on the reaction force. Okay, so on the solution here, so maybe kita boleh tengok new force, axial force. Okay, nampak ni ada keluar axial force. So biasa kita tengok under elements. Nampak ni, saya dah boleh nampak dah axial force on my elements. Okay, kalau nak tengok dalam bentuk table boleh, you klik kat sini. Okay, so you boleh cari sini axial force, nampak ni, axial force. Katakanlah pada semua elemen, I just update. Nampak ni, dah ada dah. So I just copy this. Copy to report. And then kita boleh paste kat sini lah. Okay, so notes number 1 dekat sini lah. So biasa kita bukan tengok pada notes kita tengok pada elemen sepatutnya. Sekejap ya, sepatutnya kita klik on element. Saya silap update. Okey, baru betul. So elemen sepatutnya kita kena tengok result tu. So yang ni tak betul, kita paste kat situ balik. Okey. Okay. So element number 1 this is element number 1. The axial force is in compression. Element number 2 also in compression, tapi nilai dia lebih separuh rendah daripada ni lah. Element number 3 pun still in tak ada forces. Dia tak ada forces. Okay. Element number 5 dekat bawah ni pun tak ada forces. Zero member forces. Element number 6 dia ada compression force. Okay. Element number 7 tension. Okay. Dan you boleh tengok segala-gala lah. So I don't have to do any structure analysis. Apa lagi kita nak lagi lepas ni? Stresses. Okay. If you want to know the stresses, you can click on the solution ya, button kanan New force and moment, you boleh tengok sini mana stress. Again, new stress So click on the stress. Okay, tak boleh keluar. So warna merah tak boleh keluar, tak apa. So kita pergi balik kepada solution, stress, principal stress pun tak boleh keluar. So kalau tak boleh keluar tak apa, kita boleh tengok dekat sini Okay, so yang ini mau tak mau kita kena buat manual. So if you want to know the stresses, you have to know the area. Area of nodes number elemen number 1 berapa? So kalau nak tahu senang saja, elemen number 1 will be here by the top chord. So saya kena ambil lah dia punya area kat sini. Ni. Saya kena copy. Ini kena buat manual sikit. And to know the stresses, senang saja, you cuma divide lah. You cuma buat equal force divided by area. Nampak? You akan dapat negative 19 Newton per meter square. Yang ini semua kita kena buat manual lah. Ini 0.81. Okay. Elemen number 2 pun masih lagi top chord. Elemen itu pun top chord. Elemen itu pun top chord. So maksudnya dia adalah 0.81 lah. So ini kita boleh copy je lah. Sampai elemen number 3. Yang ni semua boleh copy. So nak tahu stresses, you just double click here. Sorry. Double click saja kat sini, dia terus update Ini kacau. Okay. So yang ni dia akan dapat 0 lah sebab dia tak ada nilai area kan. So untuk elemen number 4, elemen number 4 yang mana pula? Yang ni So ini intermediate element So kalau intermediate berapa area dia? Cuba tengok edit. Area dia yang ini. Cross section area. So saya copy and I just paste dia. So if I update, ini dapat 6. So do the same thing lah for the whole thing. Then you can get the stresses. So ada sedikit kerja sini lah untuk nak dapatkan diri area. And you can get the stresses automatically by using formula. Ada formula kat sini kan, saya bagi sini. And view the deform shape. So deform shape tak boleh nak tengok sangat sebab our diffraction is too large. Kalau you tengok tadi pun, kita punya diffraction is too large. That's why gambar dia tak dapat. Nampak ni? Dia jadi pelik gambar dia. Nampak ni? Okay. So maybe kalau kita nak yang ini, jadi kita kena guna force yang kecil sikit lah baru dia dapat displacement yang agak okey sikit. Sebab kalau you tengok dia punya displacement, tengok kat table ni, displacement dalam X kalau you update saya tak pilih ni, katakan saya pilih all. Nampak ni displacement, very small. Okey lah, taklah besar sangat small aja. So kalau dalam Y, kalau kita update, still yang ni yang besar ni nampak ni. At nodes number 3 nampak ni. Displacement ni besar gila. Okay. Displacement in X kecil tapi Y tu besar gila. That's why dia tak boleh nak display because it is too impractical. Kenapa jadi gini? Because our section is too small ataupun our load is too high. Okay. So saya bagi contoh yang tak practical lah, where the example giving you a very large deformation. So kalau dia punya forces ni very small and then the right section yang saya gunakan sepatutnya dia tak terlalu besar lah. Okay. For truss element, you don't have to conduct any convergence study. Why? Because it always the same. Kalau you buat bahagi macam mana pun, result dia akan sama. But untuk beam, untuk wall, untuk slab, you have to perform apa benda ni? Convergence study. Okay. So I think that's all for today. It's not so long because it is very easy. And please apply this when you do your project. Ada apa-apa soalan tak setakat ni sebelum kita stop the lecture? Ada apa soalan?
Tak ada sir.
Okay, kalau tak ada saya rasa kita stop setakat ini. Cuma
Sir.
attendance saya set you untuk 2 jam So mau tak mau pukul 10 nanti you kena tick jugalah. Saya tak tahu sekarang. Ya?
MECWAY tadi displacement fail sebab dua area besar dengan satu apa?
Satu lagi, load besar ataupun cross section kecil sangat.
Oh, area cross section yang kecil lah.
Yalah, bila cross section tu kecil, displacement lagi besar lah. Maksudnya member kita yang kita pilih tu tak sesuai. Maksudnya as engineer you kena design section yang sesuai until deflection tu kecil. Sebab itu kita perlukan engineer. Sebab engineer yang akan tentukan size tu. Software tak boleh tentukan size. Manusia yang akan tentukan size. Software cuma bantu untuk analisa je. Kan? So tadi nampak besar gila kan? Sebab section you maybe kecil sangat. So you kena besarkan until that displacement is within certain value lah. Okay? So macam mana tahu certain value tu? You kena tengok still design punya code of practice. EC3. EC3 where you have allowable displacement of any structure. Kalau tak salah saya L/360. L adalah panjang kita punya truss bagi dengan 360. So kalau panjang truss tadi adalah 6 meter kalau tak salah saya. Sebab 222 kan, 2.5 kan, 2.5 kali 222. So 6,000 bagi 360, berapa dia punya allowable kalau tengok. 6,000 bagi 360 ke 300, something like that. Ini kena tengok code of practice So 6,000 bagi 350 ataupun 360 kalau tak salah saya. So sepatutnya displacement kita tak lebih daripada 16 mm. Sebab 16 mm ni pun dah nampak turun lah unit thrust tu. Tadi kita punya thrust displacement dah beribu, which is not logic. So kalau dah beribu tu maksud dah patah dah benda tu. So kenapa patah? Maybe our member section is too small. Nampak ni? Paling maksimum ini dibenarkan. Tak boleh lebih dari ini. So as engineer, you kena design your section tadi dengan keratan yang tertentu lah supaya satu nampak cantik. Sebab you nak kena puaskan hati arkitek. Satu lagi, you kena puaskan hati user supaya deflection is not too excessive. Dan ketiga pula, you kena pastikan is constructability. Is easy to construct. So 3 perkara ni you kena puaskan. Baru you punya design tu diterima. So tak senang nak jadi engineer. You kena puaskan banyak pihak. Sebelum you punya benda tu boleh construct dekat tapak. Boleh Tak ada soalan?
Tak ada. Thank you, sir.
Okey. Saya tak pasti attendance you boleh tick sekarang tidak, saya tak pasti. Tapi saya buat 2 jam So you tick macam biasa. You future. And I think thank you for attending the class. And that's all. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam, sir.